Hi everyone, Professor Baldwin here. Today we need to factor, and we're asked to factor this polynomial that only has two terms. But notice that each term is something cubed. So the first term is m cubed, and the second term, well, 64 is the same as 4 cubed, and we have n cubed. And using our exponent rules, we can rewrite that second term as 4n cubed. So we have a difference of cubes, which means we need to recall how that factors, because it's a special form of factoring. And the rule is when you have a cubed minus b cubed, it's equal to the binomial a minus b times the trinomial a squared plus ab plus b squared. Now, the neat thing about the difference of cubes and the sum of cubes, each of these 5 terms in our factored form stays the same. So it's always an a, then a b, an a squared, an a times b, and a b squared. The only thing that changes are the signs in between those terms, and they follow the rule of SOAP. So the S stands for the same. So the sign of this binomial is the same as the cube that you started with. Since we started with a difference of cubes, our first term is going to have a difference. And then the O in SOAP stands for opposite. And then the AP, that last symbol is always going to be positive. So your signs always follow same, opposite, always positive. And knowing that, we just need to identify what's our A and what's our B in our given cube. So our given cube, our A here is actually the letter M. And our B is 4 times n. And knowing that, we can just substitute it into this formula. So we have A minus B, or M minus 4n, times a squared, that would be m squared, plus a times b, m times 4n, plus b squared, or 4n, that whole thing squared. Now we just need to simplify. Our binomial is as simple as possible, m minus 4n. The first term of our trinomial is just m squared. We want to change the order of the terms here. So m times 4n, the constant goes first, 4, and then we like to put our variables in alphabetical order, so m, n. And then we have to actually square 4n. So 4 squared is 16, and n squared is n squared. So we have our final factored form for this difference of cubes.